Mohon perhatiannya sebentar kepada seluruh partisipan. Sembari menunggu dimohon untuk men-scan QR yang sudah disediakan di depan. Terima kasih.
able to participate. I also grew up, I told you, drinking water from that river where we did everything. And every week, no failure, I would get a stomachache. It was only when I went into second year biology high school that I learned about microbiology. And I told my parents we need to boil our drinking water and what a difference it made. That's the impact of STEM education in remote communities like Loxado, like my village. And so together with the other members of Pueblo Science, we have made it a mission to go around the world, including the Philippines, Indonesia, Caribbean. We've also been to India and South America to be able to help teachers like you engage the students in classroom, because that's where we start. That's where we need to make that difference. And it's teachers like you who are committed. Thank you for coming today. It shows commitment, by the way. Thank you for attending this training. Know that you are committed to improving education in your classrooms. It's a testament of you being here today. So thank you so much for being here. And I hope you continue to be curious, you continue to be innovative, you continue to collaborate amongst yourselves and with us. We hope that this is the beginning of our collaboration. Perhaps come back again next year for another training if they invite us again, or email us. We also provide online visits to classrooms, so we can help you with science fair projects of your students, whatever you need. We're open to collaboration with individual teachers, with schools, with universities. So with that, I'd like to thank you everyone again, and thank you, Ms. Yasmin, for inviting us. Terima kasih. I look forward to meeting you all at the session.
Thank you, ma'am, for your message and information inspiring word. Next, I am honored to invite the Vice Dean for Student Affairs of the Faculty Teacher Training and Education, Dr. Ali Rahman, MPD, to deliver the welcome address and officially open the workshop. Mr. Ali Rahman, the floor is yours.
Handphone. Bu Saukina, Bu. Punya siapa? Assalamualaikum warahmatullahi wabarakatuh. Yang saya hormati Pak Penasehat Bidang Kerjasama WLM, singkatnya seperti itu. Bapak dan Ibu sekalian, ini mohon berdiri Pak Penasehat, supaya teman-teman mahasiswa juga Bapak Ibu sekalian tahu. Bapak Ibu sekalian, inilah beliau yang menangani kerjasama di WLM ini, gitu ya. Yang saya hormati Pak Agza Santana Puba, terima kasih Ketua Program Studi. Yang saya hormati juga Mayros Salvador beserta tim. Yang saya hormati Bu Emma, Bapak Ibu dosen, ada Bu Saukina juga selaku Ketua Panitia Pelaksana, Bu Yasmin, terima kasih. Yang saya hormati semuanya adik-adik mahasiswa, seluruh teman-teman panitia yang melaksanakan kegiatan hari ini, izinkan saya menyampaikan sambutan secara singkat saja. Welcome to FKIP WLM Mayros, gitu ya. Terima kasih banyak sudah hadir di sini selama nanti sampai tanggal 29, gitu ya, tanggal 29, alhamdulillah. Dan adik-adik sekalian, mahasiswa, mari kita belajar bersama-sama tentang STEM ini. Pergunakan sebaik-baiknya, manfaatkan sebaik-baiknya, dan amalkan ini juga sebaik-baiknya sebagai menambah wawasan kita semua, terutama dalam pengembangan ilmu STEM. Mungkin Bapak dan Ibu sekalian, saya singkat saja menyampaikan ini dan ini saya sekalian membuka kegiatan ya Pak ya. Baik, terima kasih Bu Sokina, Bapak dan Ibu sekalian. Mari kita sama-sama mengucapkan basmalah. Kegiatan hari ini workshop Public Science 2025 Time Activities for Student Mental Health Resilient dengan resmi saya nyatakan dibuka dan siap dimulai. Demikian teman-teman, Bapak dan Ibu semuanya, sukses untuk Bu Sawikina bersama tim. Saya tutup, saya akhiri. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, sir, for your warm welcome and inspiring words, and for officially opening today's workshop. We now proceed to the signing of cooperation documents between Universitas Lambung Mangkurat and PUEBLO Science. For the signing ceremony, first I invite Dr. Myros and Martin. First, I invite Dr. Mayro Salvador, Martin, Dr. Andas Parmasihat, Dr. Ali Rahman, and Mrs. Emma Rosana Febrianti to sign the Memorandum of Understanding. Please give them a round of applause. Finally, I invite Dr. Harja Santana Purba MCom to sign the implementation agreement. For Dr. Myros to stay here. Stay over here. Yes. Oh, please, Mr. Mrs. Yasmin. Yeah. Please remain at the front. Please, for Pablo Science team, please, I invite to remain at the front because we have prepared token of appreciation and sasirangan shawl. All of them. Please at the front. May I invite Dr. Andes Parmasihat to give sasirangan shawl for the Pablo Science team. And may I invite Dr. Ali Rahman to present the token of appreciation.
Nur nawir qulubana binuri marifatika wal hidayatika kama nawartas samawati wal ard abadan abada birahmatika ya arhamar rahimin. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana hablana min azwajina wa dzurriyyatina qurrata ayuni waj'alna lil muttaqina imama. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Fahmi. The praise session marks the end of this ceremony. We will now proceed to the workshop. Distinguished guests may continue with your other commitments, or you are welcome to stay. Participants, please remain seated Wait a minute, we will introduce the Pablo Science team and enjoy the science demo they have prepared. Refreshments are available. Thank you.
Okay. Hello, Assalamu alaikum. Uh, uh, my name is Hamza. I'm a PhD student at the University of Toronto. So I'm studying patients who have heart disease, so cardiovascular disease, and using machine learning and artificial intelligence to help us predict who might have a heart attack or who might have a stroke, who might need surgery. So we're trying to see if we can make patient care better in patients. Thank you so much for having today. I'm excited to meet all of you and talk about some machine learning with you all. So thank you so much. Assalamu alaikum.
Waalaikumsalam. Mungkin diartikan sedikit ya, mungkin tadi terlalu cepat. Jadi Hamzah ini dia lagi menjalankan PhD-nya dan risetnya itu tentang bagaimana sih kita mendeteksi penyakit jantung, penyakit stroke secara dini gitu. Jadi dia sekarang sedang menyelesaikan PhD-nya. Mungkin itu aja mungkin dari dia tadi ya. Tadi that's quite long. The next one.
Oh, hi. Hello, everyone. My name is Natasha, and let me see. I had done my undergraduate degree at the University of Toronto, studying immunology and human biology. Shortly afterwards, I had done a master's in the Institute of Medical Sciences with a specialization in cardiovascular sciences. And that's what, at least if you're going to be in my session today or tomorrow, that's what we'll be talking about. So I'm really looking forward to working with all of you guys. Right now, I'm actually working in pharmaceutical marketing, but later on this year, I will be starting medical school. So thank you so much. I look forward to learning and working with all of you today. Thank you.
Ya. Kalau yang ini Natasha, dia udah nyelesain master degree-nya, dia juga sama bidangnya sama si Hamzah tentang jantung gitu, kardio gitu. Dia sekarang kerjanya di pemasaran farmasi, tapi dia udah berhenti, nanti dia akan jadi peneliti setelah ini. Oke, next one. Mereka berdua dari Toronto ya, University of Toronto.
Hi everyone, good morning. Saya nama Steven. That's all I know. I'm a chemist from the Philippines, but my main work is in education. I do curriculum development and I work with e-learning companies like Quipper and Canva. So I work with them to create materials for science education. I was here last year for the first RISE in Indonesia, and I'm excited to be here again for the second installment. Thank you.
Thank you. Yang ini agak panjang ya. Yang ini namanya Mark Steven Santiago, dia kerjanya, sebenarnya dia adalah seorang ahli bidang kimia, cuman dia kerjanya di bidang pendidikan. Sekarang dia bekerja di perusahaan e-learning kayak Quipper, Canvas, dia bikin bahan-bahan dan dia mengembangkan kurikulum. Jadi kalau kalian ngelihat pakai Quipper, pakai Canvas tuh dia orang di balik itu. Terus dia tahun kemarin dia udah ke sini dan dia sangat senang bisa kembali lagi ke sini. Begitu mungkin ringkasannya. Next one.
Hello, good morning. Saya Renish Simon, saya seorang fisikawan. Thank you ChatGPT for translating that.
Thank you.
I'm Renish Simon, I'm a physicist. I'm connected at De La Salle University where I handle both undergrad and graduate physics courses. So currently I'm doing some research in optical materials, and yeah, I look forward to seeing you in my session. Thank you for having me here, and yeah, this is my first rise in Indonesia, and I look forward to it. Thank you.
Thank you. Oke, kalau yang ini namanya Renish Simon. Dia dari Filipina, tapi saya tadi nggak ngerti ya, nama universitasnya agak susah, bahasa Filipina, jadi ya dia adalah seorang fisikawan. Terus dia sekarang lagi bekerja di alat-alat optik, yang dia kerjakan itu adalah alat-alat optik, dan dia sangat senang dan bersemangat untuk bisa ketemu kalian di kelasnya dia. Next one.
Hi, my name is Martin. I completed my PhD in computer engineering at the University of Toronto, and I had a company before. I developed scientific instruments for 8 years. Then I went to work for medical devices. I built medical devices, and then now these days I work full-time building robots. So at the end of this year, my robots there will be more than 7 million of my robots in the world. So I look forward to exchanging with you, and I look forward to discussing interesting things about robotics. Thank you.
Okay, thank you. Nah, kalau ini Martin Labrek ya, dia udah nyelesain PhD-nya di bidang computer engineering. Is it computer engineering? Ya, computer engineering. Jadi dia kerjanya tuh bermain dengan software. Dia juga sekarang bekerja di perusahaan yang bikin-bikin robot. Sekarang lagi bikin-bikin robot, terus bikin-bikin software. Mungkin kalau kalian tahu mainan-mainan anak-anak yang yang kalian lihat di Shopee deh, kebanyakan tuh dia yang bikin gitu. Kayak mungkin dia nggak bilang ya, tapi dia kemarin cerita kalau yang kayak mainan di apa sih namanya yang Paw Patrol ya, itu dia bikin kayak gitu, Paw Patrol kayak gitu-gitu sih. Jadi dia banyak yang tentang software, komputer dan lain-lain. Jadi dia sekarang lagi bekerja di bidang robotik, begitu. Setelah ini mungkin Martin akan kasih beberapa ini ya. He will give some presentation about robotics. Jadi setelah ini dia akan kasih sedikit pemaparan, pengenalan tentang robotik, supaya nanti ketika di kelas dia nggak kaget. Jadi nanti saya langsung persilakan aja kah? Oke, saya persilakan kepada Martin untuk memberikan materinya. Please Martin, give your.
All right, so I guess we will start the technical part of our presentation, right? So first, before we begin, I'd like to encourage every one of you to take advantage of these people who have traveled. Some of them have traveled very far, and make sure that before you leave is a microcontroller. So in our robot, we will have a microcontroller. And a microcontroller is a small computer that is connected physically to the hardware. So we have a lot of connections, and this microcontroller will execute a program. The program will be stored in the memory of the microcontroller. And to write the program, we'll either write code. We can write code with using words, or we can use a block-based visual development environment. So in our workshop, we'll focus on the block-based visual environment. So it's a good way for the students to learn quickly and get a rapid initiation to the robotics using drag and drop blocks.
Oke, jadi microcontroller ini sederhananya seperti motherboard kecil ya, yang di dalamnya itu nanti akan diinstal ada program yang digunakan untuk membaca masukan input, kemudian memberikan outputnya. Nah nanti untuk menulis programnya kita akan menggunakan visual code atau block based code ya, jadi tidak coding tulisan tapi menggunakan block kode seperti itu.
All right, so going to the next slide. This was what our microcontroller, our brain, the brain of our robot will look like. So you can actually buy this. It's widely available. The name is ESP8266. There's a small typo there. And the interesting thing to notice on your board, when you look at your robot, you'll find out that there is no components on the main board. The main board is only to accomplish the connection between the brain and the inputs and outputs to your car. So this way you can really see all the parts of your robot and you can really understand what each part does. And then we'll go through what connects to what in the different sessions. Yeah, so now how do we program this chip? How are we going to give commands to this? How are we going to put commands into the brain, this brain? So we're going to use a block-based environment. This environment is we're going to program it visually. And you have to keep in mind that the program runs one step at a time. So you can see on the image there. So it's like a conveyor belt, right? We have boxes going through our factory. And for every box, we have a processing to do. So the box goes on a conveyor belt. We process every box. And then there could be instructions to say the box can go left or the box can go right, depending on the conditions in the program. One thing to remember is the sequence of instruction runs very, very fast. So the program runs one step at a time, but can run more than 80 million steps per second. So it is very fast.
Oke, jadi nanti untuk pemrograman berbasis bloknya adalah kita akan merangkai serangkaian langkah. Nanti kita akan menyusun seperti Lego gitu ya, block by block. Kemudian nanti kita akan memberikan instruksinya dan kita juga bisa melakukan perulangan di sana gitu. Nanti dalam satu kali running itu kita bisa menggunakan hampir 80 juta instruksi ya, seperti itu.
So given that our program is very fast and it runs millions of instructions per second, we cannot write millions of instructions. So we need to use loops to repeat the same instructions. So on the next slide, so this is what a loop looks like. On the left side of this, we can see what it looks like in code. So if you were to write the code for your loop, you'll have a for loop that says for integer, we say I or II equals 0 to 10. And then we increment, for every step we will increment the integer and we will print the number. And then we will get the result on the right side of this box. We see like it will print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how we can repeat the code 10 times. But when we use the visual environment, we will have 3 options. So you can see there's a so we have a loop. So we have a repeat block that can loop 10 times, for example, or we can have repeating while something is true, or repeat until something happens, right? So there's different options for a loop block. So you'll be able to use these blocks in your program later in your session. So this is how you're going to repeat your block. So now what happens if the code finishes? So if your code finishes, right, the microcontroller will just keep going. So in our case, we will stop the program. As soon as your program is stop executing, then we will stop the execution, we will stop the motors and any action that goes on into your microcontroller. So that's why it's very important to loop your program. Yes?
Oke, jadi nanti kita akan melakukan programmingnya itu dengan blok kode yang sebelah kanan. Jadi mungkin bagi teman-teman yang tidak familiar dengan coding gitu, biasanya kita menulisnya secara manual sebelah kiri, yang sisi hitam ini gitu ya menggunakan bahasa C. Tetapi yang hari ini kita akan menggunakan block code seperti sebelah kanan. Jadi cukup tahu bahwa repeat 10 times artinya mengulang 10 kali. Do artinya lakukan apa gitu ya. Jadi kita tinggal menyusun kode-kode ini gitu ya untuk sesuai dengan langkah nanti yang ditentukan. Jadi tidak perlu menulis yang sebelah kiri, tetapi kita akan menyusun blok kode. Seperti itu.
Alright, so other than loops, we also have if statement. An if statement is something that decides which way the program goes. So you can say if the input is 0, then we say it's a man. If the input is 1, it's a woman. Otherwise, we don't know, right? So we execute one instruction depending on the if or else. So when we use a block-based interface, we can compose, we're gonna click the little blue box there on the corner of the if statement, and then we drag the little pieces under the if statement to create if, else if, and then we can finish with the else statement. So if this is true, then we execute the instruction inside the block. So you can see the curly brackets in the code. We have a block that gets executed. So that's what the block will look like in your visual environment.
Oke. Jadi yang sebelah kiri adalah contoh untuk percabangan. Yang sebelumnya tadi kita menggunakan perulangan gitu. Sekarang kita percabangan ya. Nah, kalau yang sebelah kanan nanti kita cukup menggabungkan gitu komponennya tulisan if kemudian kondisinya apa gitu ya. Maka kalau kita sesuaikan input sama dengan 0, kemudian do-nya adalah nanti akan ngeprint misalkan atau mencetak kata mail gitu ya. Jadi ada if, ada else if. Kalau misalkan dua kondisi tidak terpenuhi, maka dia akan jatuh ke kondisi yang ketika kondisinya terpenuhi, apa yang akan dilakukan? Seperti itu.
Alright. In order to read the signal to use the input to the microcontroller, we have two types of pins. The pins that are on our microcontroller are either digital or analog. So when you have a digital input, it means you read the voltage on the pin. Right? So the voltage can either be high, and then we'll read a 1. If the voltage is low, then we'll read a 0. If it's in between, we don't know. So it's better to not stay in that region. And this is what the circuit looks like with the two transistors to, if we want to output a high voltage or output a low voltage, then we'll have the voltage go to the supply voltage or to the ground level, to 0 level. So that's for the digital pins. And for
Baik, jadi kalau yang untuk microcontrollernya nanti ada pin digital umumnya gitu ya, yang bisa digunakan untuk input tegangan tinggi dan atau tegangan rendah, sedangkan yang dimiliki oleh Pueblo nanti itu dirancang memiliki satu pin input analog yang khusus membaca tegangannya adalah sekitar 0 sampai 1023. Jadi ada komponen khusus nanti dari microcontroller ini punya si Pueblo, gitu.
Alright, so, and then the next part is on our microcontroller, we have one analog pin. Let's just go back to so the analog pin allows you to read the analog voltage. So you'll deal with thermistors, temperature sensor, humidity sensors, and these are analog voltage. So it's a continuous curve, but the microcontroller reads the signal and converts it to a number, a discrete steps. So you can see how the curve was converted to digital steps using the analog to digital conversion. And our microcontroller will read the analog signal and convert it to a value between 0 and 1023.
Jadi seperti yang tadi sudah saya jelaskan gitu ya. Jadi nanti pin analog ini akan menerima input ya, berbagai macam input, suhu dan lain sebagainya secara continuous. Kemudian nanti akan didigitalkan menggunakan komponen ini nantinya. Seperti itu.
Alright. Now, our robot actually today will be a car. So in our car, we'll have two servo motors. And what is a servo motor, right? So why do we call it a servo motor? A servo motor is composed of 3 parts. So the first part of a servo motor is a DC motor that uses DC voltage, a steady voltage. So that's the first part is a DC motor. The second part is a gearbox. So you can see on the photo, there's all these gears that turn. And the purpose of the gearbox is to reduce the speed and increase the torque, increase the force of the motor. So otherwise we'd have a very fast spinning wheel, but very weak. So we want it to turn more slowly, but with more force. And there's a logic circuit in the in the servo motor that interprets a command from the brain, from the microcontroller, and converts it into a power signal that then goes to the DC motor. So, and on the right side, you can see the waveform that the microcontroller gives to the logic circuit to convert into a power. So we can drive the servo forward or backwards.
Baik. Jadi nanti ini dijelaskan adalah motor servo gitu ya. Untuk ada 3 komponen di sini seperti yang terlihat. Ada motor, ada gearbox dan rangkaian logika ya. Jadi nanti untuk kode yang tadi kita buat itu sebenarnya kita tanamnya di rangkaian logika. Kemudian nanti dia akan menjalankan ke motor. Kemudian motor ini akan mengubah daya DC menjadi gerakan yang dimana nanti dikaitkan dengan si gearboxnya ya. Mengurangi kecepatan kemudian meningkatkan torsinya. Seperti itu.
So as we build our robot, on the next slide, so our servo looks like this. It's a small blue servo motor. It's very small, not very powerful, but the same concept that we're going to learn today in this workshop, how we can drive a servo motor, how we can give commands, how we can read inputs, all of this applies to even industrial motors that have real power. So you can actually think about building a device, a real device that can help you in your daily life using the same principle that we're going to learn in this workshop.
Baik, jadi tadi ada beberapa komponen gitu, tetapi si PUEBLO membuat komponen yang lebih sederhana sehingga bisa digunakan untuk percobaan-percobaan kecil gitu ya. Jadi ini mirip dengan seperti yang sudah ada di industri, tetapi untuk skala yang lebih kecil.
Alright, so now I'm going to cover some basic principles about electric circuits, just so that we understand how the circuit works when we're going to connect things and how we build a circuit. So basically, when we have an electric circuit, we have a conductor, and in the conductor, there's electrons that move, and that creates a signal that transfers power into the electric circuit. And there are 3 main parts to an electric circuit. There's a voltage. The voltage is what you can think of it as a water system, right? The voltage is the one that puts pressure into the hose, or you could have a waterfall. The more pressure you put on the water, the more flow you are going to have in your hose. The current is the flow that goes into the flow of water that goes into the hose. So you can define it by the size of the hose. A bigger hose will be able to drive more current. And the resistance is what limits the current. So if you have sand, for example, in your hose, it can really reduce the amount of current that can go through. So these are the main 3 parts of understanding how the electricity works.
Baik. Jadi untuk listrik sendiri di sini ya, electricity itu seperti selang air ya. Jadi mungkin teman-teman IPA dan juga yang lainnya ya. Ini kalau dari komputer agak-agak ini nih. Jadi kalau voltage itu mirip dengan tekanannya ya kan, tekanan airnya. Kemudian kalau current itu adalah ukuran dari selangnya. Sedangkan resistance itu adalah partikel yang ada di dalam selang itu gitu. Hambatan ya, resistance. Oke, gitu.
Alright. So when we build circuits, we have 2 types of circuit. We have in series. When we say we build a circuit in series, it means we connect the elements back to back, right? So we have 2 batteries on the left side. We have 2 batteries. So that's what the series looks like. We just attach them so that the electricity flows in a loop. So that's in series, and that's in contrast with the parallel circuit. The parallel circuit means they're all connected in parallel. You can see the LED and the resistor parallel. So we have to understand.
Baik ya, jadi ini adalah rangkaian sirkuit sederhana. Seharusnya anak-anak IPA ini sudah lazim ya ada di SMA mungkin ya. Tapi bagi teman-teman komputer yang dari SMK nanti akan belajar langsung di workshopnya ya. Jadi ini ada rangkaian seri, nanti mungkin akan kita buat, kemudian ada rangkaian paralelnya ya. Baik.
Alright, so now when we have a circuit, we want to know how much. We want to put some numbers in our circuit. So the main principle that drives how much or what we calculate in a circuit is the Ohm's law. Ohm's law is what relates the voltage, the current, and the resistance. So the current times the resistance equals the voltage. And then we can rotate this equation around to say the current is equal to voltage over resistance, or resistance is equal to voltage over current. And this is the most important principle when we talk about circuit.
Baik, jadi ketika membangun sirkuitnya nanti, ini adalah rumus dasarnya gitu ya. Jadi mengetahui hukum Ohm ini dan mempelajari rumus nanti yang ada di depan gitu.
So on the next slide, we're going to learn about a short circuit. A short circuit is what happens when there's a path for the conductor, for the electricity to flow from one side of the power source to the other side. So you can imagine that if you have your waterfall, and instead of the water going in the waterfall to accomplish a load or to accomplish some work, it goes straight back to the bottom. It goes straight to the bottom. So instead of flowing nicely in the waterfall, the current goes straight to the bottom. So if you have a circuit, for example, and then you take your circuit and then you wrap it in foil paper, for example, that would create potentially a short circuit because it creates a connection between the battery. The two sides of the batteries will then be connected through a conductor. And if we use Ohm's law, then we can calculate how much current goes into a short circuit, right? Can you help me calculate how much current would go through a short circuit? Maybe we need to.
Can you repeat again?
Sorry?
Can you repeat again?
Yes, so I was explaining about the short circuit. So when we have a short circuit, we have a path that the electricity can flow between the two sides of the battery. And that means that there's a very low resistance between the two sides of the battery. And so now what kind of current are we going to get in our circuit when we have a short circuit?
Iya. Jadi tegangan itu kan dia mengalir di sepanjang rangkaian itu kan. Nah, jadi hambatan antara yang negatif sama positif itu sangat kecil. Jadi nanti ada arus yang mengalir di dalam sana. Itu mengikuti arus yang rumus yang ada di samping. Nah, kalau misalnya tadi dia pakai permisalan itu pakai misalnya kayak air terjun, arus itu dia tetap akan mengalir ke bawah walaupun nanti bebannya akan turun ke, kalau kita ngeliat air terjun itu airnya dari atas ke bawah gitu kan ya. Tapi arus tetap akan turun ke secara vertikal ke bawah begitu. You can continue.
So what do you guys think? If I put R to 0, what happens to I? What is I if R is equals to 0?
Kalau misalnya hambatannya 0, apa yang terjadi pada arus? I. Ada yang bisa jawab? Kalau misalnya R-nya 0, apa yang terjadi pada arus atau I? The current will be 0 as well.
The current is 0 in a short circuit. So I have voltage. My battery is 1.5 volt. I have 1.5 volt battery. R is equal to 0 because I use a foil paper, very low resistance, and I wrap my battery with foil. How much current will I get in the foil?
Nah, kalau misalnya I-nya juga 0, berarti tegangannya juga 0 dong. Ya.
So if I divide something by 0, what happens? Have you ever
Yeah.
divided something by 0? That's not good, right? Dividing by 0 is not good. But you can actually build a circuit that divides by 0. So what happens to the current? Is it very high or very low?
Terus arusnya gimana? Jadinya sangat tinggi atau sangat rendah? Kalau misalnya R-nya sangat kecil, hampir 0.
I have an answer here.
Tinggi atau rendah?
The current is very high, right?
Ya.
Yes. So if you take a piece of metal and then you put it on the wall socket, you'll get a very high current between the two sides of your prongs on your socket. So that's why we want to avoid short circuit. When we deal with circuits, we want to make sure that we're not creating a short circuit. So that's what protects our battery. Otherwise, the charge in the battery will be discharged very quickly because of the high current.
Ya, jadi nanti kalau misalnya kita akan memastikan bahwa hambatan itu sangat kecil supaya arusnya nanti besar. Kalau arusnya besar nanti tegangannya juga dia akan lebih cepat ngisi baterainya.
Alright, so now on the next slide. So this is a principle that we're going to learn just deriving from the same principle, right? We have a resistance. In this case, we use Z instead of using R, but it's the same idea. When we have a voltage divider, we can calculate the voltage V out. We can calculate the voltage V out based on the current that goes through, and then we can calculate so if we know the basically in our circuits, we'll learn more about thermistors in our circuits, and then you'll be able to refer to this equation here that allows you to calculate the resistance in the circuit based on the voltage and the current that goes through, and then you'll be able to calculate the temperature on this circuit. So I think Stephen will come back to this later.
Oke, jadi kalau ini rumus untuk yang membagi tegangan ya. Jadi kita tergantung nanti mau tegangan input, tegangan outputnya yang dihitung di mana. Pakai rumus yang di samping, Z itu impedansi. Jadi nanti kalau misalnya mau lihat yang V input, V output sesuai yang digambar, berarti kan impedansinya cuma Z1. Nanti bisa referensinya adalah rumus yang di samping. Nanti mungkin karena ini hubungannya nanti ke kimia, katanya nanti mungkin Steven nanti akan nambahin.
All right. So now that we've covered the basic principles, I'm gonna give you some questions. So you guys maybe take out your calculator so we can start thinking about some numbers.
Oke, coba keluarin kalkulatornya. Silakan dikeluarkan kalkulatornya, nanti dia akan kasih beberapa pertanyaan.
Okay. So in our robot we have three batteries. So 3 batteries is 1.5 volt times 3. That makes it 4.5 volts. Now, when we turn on the robot, the minimum current is about 80 milliamps. Milliamp is the amount of current that goes into the circuit just to turn on the circuit. If your battery voltage is lower, because we use a boost converter, the current is actually higher because I'm going to come back to this later. But now when we turn on both motors, sorry.
Jadi ini nanti kita ada 3 baterai, dan satu baterai itu kan 1,5 volt. Nah kalau 3 berarti ada 4,5 volt. Kalau motornya nanti dinyalakan, nanti ketika baru nyala itu arus minimumnya adalah 80 miliampere. Nanti ketika waktu terus berjalan ya nanti tegangannya mungkin akan turun karena beberapa hambatan dan lain-lain. Nanti minimal arusnya menjadi 120 miliampere.
So one battery on average is about 2,500 milliamp hours. So milliamp hours is a milliamp, is the amount of current, times the time, hours, milliamp hours. So if we let's say we turn on both motors at full speed, and we know that it takes about 700 milliamps or more, then how long can we run our car if our motors are running at full speed?
Oke. Satu baterai itu kapasitas rata-ratanya adalah 2.500 miliampere jam, mAh ya. Nah, kalau misalnya kita nyalain motornya dengan kecepatan penuh, nanti dia arusnya akan menjadi 700 miliampere. Nah, berapa lama sih kita bisa menjalankan robot kita jika kita pakai satu set baterai yang 3 ini? Siapa yang bisa ngitung? Boleh tebak jawabannya? Kalau full speed ya, kalau kecepatan penuh kira-kira berapa lama ya nyala robotnya itu? Dengan 3 baterai.
Will it run forever? Will it run 1 minute? Half an hour? How long can it run?
I think they are using their calculator now.
All right.
Anyone? Ini elektronika dasar. Anyone? Ada yang dapat nggak jawabannya? Siapa tahu dapat apa gitu? Boleh angkat tangan. Pak Billy. Berapa Pak?
3 to 5 hours? 3 to 4 hours. Yes. So
Give applause. 3 sampai 4 jam kata Pak Billy.
So the batteries are in series, and each battery can provide if you turn on your motors fully, you'll draw about 7 milliamps. So each battery will deliver the current, the necessary current. So you have 4.5, your battery capacity is 2,500 milliamp hours, and you divide it by 700 milliamps. So that gives you about 3.5 hours.
Oke, jadi cara cepatnya adalah, tadi kan kapasitas baterainya 2.500 miliampere hour kan per jam, dibagi sama arus yang maksimal tadi ketika kecepatan penuh yaitu 700. Jadi sekitaran 3 sampai 4 jam. 2.500 dibagi 700.
Now if you run let's say you don't run your car. Let's say you leave the switch on and you forget about it, you go to sleep, and then you come back the next day. Will the car still be on?
Tes, oke. Jadi misalnya nih kalian nyalain dengan set baterai tadi, kalian nyalain, terus kalian ketiduran, kalian tinggalin, terus kalian cek lagi, besoknya apa yang terjadi kira-kira? Masih nggak itu robotnya jalan? Masih. Kalau misalnya ketiduran nih, lupa udah dinyalain, ketiduran, terus besoknya kita lihat lagi, kira-kira apa yang terjadi pada si robotnya? Masih muter-muter nggak?
Any
They don't know
thoughts?
the answer.
Will your robot still work tomorrow if you forget to switch on?
Ya, kalau misalnya kalian lupa nyalain, lupa ngetik, masih nyala nggak dia? Nah, kalau yang bilang iya masih nyala bisa angkat tangan. Iya, besokannya kan ketiduran. Besokannya baru kita lihat lagi robotnya. Oh, have you switched the switch on? Have you turned on the robotic?
Sorry.
Have you pressed the button, the switch on? No.
Can you press the button?
The question, is the switch on? That's on. Oke.
Yeah.
Udah diketik. Terus dia ketiduran. Terus besoknya balik lagi. Robotnya masih jalan atau
So tomorrow at 10 a.m., will cars still be on? No. Who says yes? All right, how do we know? How can we calculate? So we know the battery can give 2,500 milliamp hours, and then tomorrow is in 24 hours, right? So if we say in 24 hours, we can deliver about a bit more than 100 milliamps, which is about the average current that we could draw, that the robot will draw, right? Because the robot, if it does nothing, it consumes between 80 to 120 milliamps, roughly. And so in 24 hours, we can consume on average about 100. So we know the battery will be dead in 25 hours at 100 milliamps. So tomorrow, there's a good chance it's still on, but not for very long, right? So.
kalau misalnya satu hari kan 24 jam ya, coba 80 kali 24, strategi. 80 kali 24 masih ada tuh, masih bisa, kemungkinan masih ada tapi kecil. Karena mungkin ada beberapa hal akan terjadi, jadi kalau misalnya kita pakai kecepatan minimum masih mungkin dia bisa masih menyala begitu.
All right, so, and then it says here, if you want to, let's say you want to save your battery because you want to be more economic on your battery, then you can turn off the switch. Go back one, please. So you can turn off the power switch on your, you can turn off the switch on your robot, you can turn it off, and you can still plug the USB cord into the robot. So you can do a lot of the functions except the motors. The motors will not run unless it uses the batteries, but everything else can run on the USB port. So, all right, on the next slide. Yeah, so now I'm going to introduce the concept of power, electrical power. So power is measured in watts, and electric energy is measured in milliamp or watt hours. So who here pays the electricity bill? You guys pay electricity? Who pays the electricity bill in their house? All right, so what do you guys pay for? Do you pay for watts or you pay for watt hours? Watt hour, right? You pay for the energy that you consume. And how much does it cost? How much for 1 kilowatt hour? 1,000 watt hours. We don't know? On the power? Every hour? Or it's different based on the time of the day? Okay. But on average, what's the range? How much does it cost, roughly, for 1 kilowatt hour? Okay. But you guys are paying for it. You should know. Right? So this is very important, right? You need to know what you're paying for. So the watt hour is the energy that you consume, and it's the power, the energy that you consume is equals. So the power is voltage times current, and then the energy that you consume, you multiply time. So that gives you the energy that you consume. So this is how you calculate the power, the voltage times current, and then you can shuffle this equation around to get the current that you consume. For example, if you know that your laundry machine, for example, how much power does your washing machine consume? Anybody knows? $450 watts? Watt hour? What is the power that your washing machine consumes? $450 watts. Okay, so if you run it for 1 hour, 450 watt hours, how much does it cost? So Stephen, can you help me with the calculation? How much does it cost? 450 watts times 1 hour, that's 450 watt hours. So that's 0.45 kilowatt hours times how many rupee per? So that costs 650 rupees? Rupiah. Yeah, 650 rupiahs to run your washing machine for 1 hour. All right. Now, let's say you use your motorcycle. How much power in your motorcycle? How much power does your motorcycle draw? Let's say you have an electric motorcycle, assuming it's electric. I know most people have gas motorcycle, but let's say you have an electric one. How much power would it draw? An idea. Do you have an idea of how much power it takes to run a motorcycle? I know they have gas, but some are electric. Some are. So if you have an electric motorcycle, or even if it's gas, even if your motorcycle is gas, you can still calculate the energy, right, in watts and watt hours. So what is the equivalent wattage of your gas engine on your motorcycle? Is it 450 watts? Is it more than a washing machine? Is it less than a washing machine? What do you think? Okay, who says the washing machine takes more power than the motorcycle? Anybody thinks the washing machine takes more power than the motorcycle? One taker? Oh, okay. The motorcycle is more than the washing machine. Yes.